Okay, we're going to look at some model problems for the Algebra 2 Semester 1 final review. Excuse me, and this is the first 5 problems. In this section, we're supposed to identify the types of numbers that are in this long list that they give us, and we're supposed to identify the integers. Well, the integer numbers are the positive and negative whole numbers. So we just have to circle all the positive and negative whole numbers. Okay, so 7 is an integer, and so is negative 6. Square root of 25 is the number 5, and that's in the list. 0 is in the list. And there it is. There's all the integers that are in that list of numbers. Okay, the next one is the whole numbers, and you can see the whole numbers start at 0 and go upwards. So just the positive whole numbers, the positive integers and 0. So the positive whole numbers would be, let's see, there's 7. Whole numbers are positive numbers and 0. 0 is a whole number, and so is 5, but this time we're not going to circle that negative 6. All right, you can see the whole numbers start at 0 and go to the right. Those are the whole numbers. Okay, the natural numbers starts at 1 and goes to the right without decimals. So this time we're limited to just the 7 and the 5. And you know the square root of 25 is 5 because 5 times 5 gives 25. Okay, the next problem we're going to look at is a little more complicated. We're going to look at which ones are rational. And the root word here is ratio, which is a synonym for fraction. So the idea here is any number that can be made into a fraction, and there's a couple of rules. If you have a numerator p and a denominator q, the bottom number there can't be 0, and we're supposed to be able to use integers for the p and q, not decimals. So any number that you can make a fraction out of qualifies. I'll just start with the integers, and they're easy. 7 could be 7 over 1. Negative 6 could be negative 6 over 1. You can see I'm making fractions out of these. 0 can be 0 over 1. And so I've made fractions out of those. Also rational are the ones that are already in fractional form, like 3 over 8. And then any terminating decimal, for instance, oh, and I forgot square root of 25, which is 5 over 1. All right, any terminating decimal, that means a decimal that doesn't go on forever, so that would qualify right there. 4.23 is a terminating decimal, and if you care, that's going to be 423 100ths. But you can see I can make a fraction out of it, so it's rational. And any repeating decimal, it's a little harder to actually show it, but any repeating decimal, like 9.222222, is also a number that can be made into fractional format. So I've got all the rational ones circled, and if you'll pay close attention, the ones that aren't rational are the pi and the root 10, which is going to help us when we get to the next slide. Irrational numbers are ones that are not rational, so we were limited to pi and square root of 10. Now pi, you know, is 3.14159265355, etc. It does not terminate, in other words, it doesn't stop, and it does not repeat, and those are the combinations that are always present when you have an irrational number. Now you can take square root of 10 on your calculator. You're going to get some really nasty number starting with, I think it's 3.162, and it just gets worse from there. But these are irrational numbers. So if you've circled all the rational ones on the previous slides, the ones that are not rational, IR is the Greek prefix that means not. Those are the irrational ones, and they will always be non-terminating, non-repeating decimals. Okay, that should get you through the first 5 problems.